Could you give us an example of knowledge transfer that we may be familiar with? So I'm just showing the homepage of the Knowledge Transfer Group here. And then you can talk in the background about perhaps an example. I can see here a medical device, for instance, a high energy physics.
So what you can see on that picture, I guess, is hadron therapy. So where you actually use a proton beam to treat cancer. So I mean, medical.
A proton beam.
Yeah.
Well, so a proton beam is a charged particle, if I remember correctly, positively charged. Like, I could be totally wrong here, and I probably shouldn't be talking about that stuff.
Well, yeah, don't talk too much about these details.
But okay, I've heard about MRIs and scanners and things like that. But it seems like a laser beam, but it's not light; it's protons, and it's used to treat a pretty bad condition like cancer. So is this something that is in the process of being commercialized?
No, so this is actually a very well-known application of
it's done.
physics. Yeah. It's very well known. One of the typical examples, because you have traditionally a lot of overlap between medical and biomedical technologies and physics when it comes to treatment, diagnostics, imaging.
Yeah. So this is a graphic that you have in the homepage here.
So this really sums up well what we do in the Knowledge Transfer Group, because at CERN, you see in the middle in the circle there, you have the three areas: accelerators, detectors, and computing. So those are the three technological pillars of CERN.
Yeah.
So we send the particle through the accelerator, they collide, like we take a picture of the result for like saying it very simply, and then we gather and analyze and visualize this data. So these are really the pillars of what we do. And to explain further how this can create applications in completely different areas of society, you can see on the left-hand side, there you got our areas of expertise, which is kind of what lies behind these three pillars. And then you can see like cryogenics, cooling and ventilation, material science, metrology, robotic sensors, superconductivity. And then it's kind of easier to relate to what knowledge from CERN can contribute to.
Yep.
And then on the right-hand side, there you see areas where you typically find applications.
Yeah. So the example that we just looked at, I'm just going to clean up here. The example that we just looked at, say here, oh, sorry, wrong thing. So in this video, which you can find in the homepage, this looks like it's a result of particle physics research, control, computing. So it's a bunch of things here. It's not just one area of research that led to the development of this technology. It's just a bunch of these things. And then it went through CERN, accelerators, detectors, computing, the things that you've got in the middle, and it resulted to a medical and biomedical technology, to this thing here. Is that, in a nutshell, is that what happened with this particular technology?
I'm not sure the history of hadron therapy specifically, but typically, yeah, you kind of rely on these areas of expertise, either being a specific technology or a piece of know-how, for instance, and then this contributes to other applications, which are often not really obvious at all.
Takes time, doesn't it? Like maybe I was just thinking maybe to have a look at how much effort is needed for something like this to come out and to be used in the public, by the public. Like we're looking here at the tip of the iceberg of the effort needed to create something like this. Behind it, I guess there's perhaps decades of work in multiple fields to make it happen. And because CERN does a lot of research in fundamental areas of science and technology, which is basically the forefront, you create new stuff. We're looking at decades worth of effort before something comes out. Is that right?
Well, it depends. If you're talking about medical and biomedical technologies, this can often be the case. If you're like for hadron therapy, where you use accelerators, these are huge machines, and you need big collaborations and studies behind it. But then again, you have other examples where like just the path of commercialization is completely different.
Yeah.
And so one thing is if you're actually using accelerators themselves, but if you have like one other thing at CERN is actually we're a huge organization, so we rely on a lot of IT systems. So that's also something we commercialize, IT systems, and those are easier to get to market quicker.
Right. The path is, so you've got a huge variety then in technologies that come through or out of CERN that become commercial products. So I guess you need to have some fairly sophisticated processors or very smart people to be able to identify where the potential is and then to push them through a process that you have to make it commercial. So can we switch just very briefly to talk about your role now in all this, and what do you do here? This looks pretty amazing, but what is exactly your role?
Yeah, so I am responsible for CERN's entrepreneurship activities. I try to create a culture of entrepreneurship in the organization, and I help people that want to start a company based on CERN.
So you use the experience that you have, specific experience that you have for creating businesses within CERN.
Yeah, exactly.
Are those like commercial businesses? Are they spin-offs CERN, or are they perhaps outside businesses that come into CERN and say, hey, we're really interested in this technology that you have developed and would like to use it in our business to build XYZ product?
Yeah, so a bit of all. And actually, I think what we have the most, so we have actually no formalized incubator at CERN. So an incubator for startups, meaning where you get to develop your idea in the early stages. But we have a network of such centers. So we have a network spread around across Europe where other ecosystems and infrastructures are committing to work on with startups that are using certain technology.
Right.
And they are, I mean, they're already existing ecosystems and incubators. And what often happens is that they actually talk to companies and then they say like, oh, wow, you can maybe use this technology or this kind of knowledge from CERN. And then you do a matchmaking and suddenly you find a match. I mean, if you have enough leads, that will eventually happen, which is pretty cool. And then you have some spin-offs, but I also, to be fair, I also help people that want to do stuff that's nothing related to CERN just because their contract is ending and they have an idea for what they want to do next. So that's kind of also part of my expanded mission, but Knowledge Transfer Group itself are mostly working on the technologies.
So you don't like, you do work with a lot of larger companies that are building these medical devices, for example. I guess to build something like that, you'd need some fairly sophisticated and expensive technology labs and ability to liaise with hospitals and doctors and a good understanding of the medical research as well as the technology. But you also go to the micro level. So you said you can have, say, a contractor or an individual who has an idea for a product, and then you can assist them as well to develop that.
Yeah, exactly.
So nothing is too big, nothing is too small. great.
Well, I mean, but for the big medical projects, I wouldn't be, like, if it's bigger companies, I wouldn't be involved. That's
Yeah.
and somebody of my colleagues. So we actually have a group for medical applications, and they are, well, I mean, they're the biggest group within the knowledge, or the biggest section within the knowledge transfer group again.
Yeah. I wanted to ask you about training next.
Yeah.
So we touched a little, and I'm going to take it back to entrepreneurship a little bit, but it doesn't have to be entrepreneurship on it only. So I wanted to ask if within the group you also offer opportunities, perhaps to CERN staff or even outsiders, for education in those areas, both in general business, but also in entrepreneurship. Because you did say that there's a lot of scientists and engineers in CERN that do have that mindset of wanting to take things to the world. So do you offer training?
So, like, the knowledge transfer group has several trainings in different areas like IP, so intellectual property and licensing, on knowledge transfer as a whole. We also get a lot of case studies if you go through this training. So these are kind of courses that are tailored for the CERN community.
Yep.
But then we also have training courses that are open to the whole world, which is something I am a lot involved in, because we have, for instance, the CERN Entrepreneurship Student Program, where we get master students from the whole globe over to CERN for a 5-week period to learn about high-tech venture creation.
Yeah. What is it like? Could you tell us a few things about it? Like, what it is like for somebody going through that program from the public?
Well, so first they come to CERN, which is a strange place where you meet a lot of people. People are very open. They start with the first week where they really need to talk to a lot of people at CERN. They need to explore.
Steep learning curve.
Yeah, and then I mean, we kind of send them out the same track as we did during my master's. So they need to do all these phone calls and
Practical, hands-on.
very hands-on. Yeah, so I mean, that's the way for entrepreneurship training. You need to do it, and of course this is education. We want them to learn, but we really want them to create opportunities so that they can start companies based on the project they have. So
is what you're talking about this that I'm looking at now on the screen?
That's it. Yes.
Right. So it's called the CERN Entrepreneurship Student Program.
Mm-hmm.
So 5-week.
Exactly.
So who is a target audience for this? Like, who is a typical student that will join this program?
Yeah. So, like, they need to be master students, and then it's a bit of a tricky mix, but you find it because we really want them to have technology backgrounds.
Yeah.
But also have some education or experience with entrepreneurship. So kind of, well, if you want to get in, if you want to be amongst the highest rated, or those who actually get accepted to this, then you need to have both components. You need to be somewhere in the middle of the scale, and that is because, well, for the technology part, it's very hard working with certain technologies, and it's nice if you have some basic understanding of this, but also we don't want to start on the basic of entrepreneurship. We really want to indulge into the specifics of the CERN context and what they can learn from that, and start the very hands-on training so that they already have part of the skill set.
It is a 5-week program, so you want to maximize the outcomes in that time. So you don't want to start with entrepreneurship 101 and talk about the very basics, right? You assume that the students have already understanding of those items. Technology, I guess, they need to have a technical background and understanding of technology, because if I understand right, they will be, through the program, they will be biased towards using CERN technologies in their projects?
Well, yeah, so they need to identify technology or knowledge or project at CERN that they can base their work on, or even be inspired by CERN.
Yeah. So 5 weeks later, like, if possible, I don't know if you have confidentiality agreements with students as part of their work there. Could you tell us some examples of successful collaborations with students or graduates or alumni that have developed something in those 5 weeks that we may be familiar with or may not be familiar with, but that you think as significant?
Well, disclaimer, like we started this program last year. So
Okay.
last year was the pilot program of the whole thing, where we designed the whole, the whole thing.
The curriculum.
And we had the first students going through, and we started out last year only with 10 students. So
what's kind of the projects that they, as an example, some of the projects that they worked on, even if they didn't eventually make it into the market, but what are the kind of problems that they try to solve in those?
Yeah, so two of the teams actually ended up working on the same technology, which is a structured laser beam.
Structured laser
beam. So you have a Gaussian beam, which is kind of a beam where when you have it close, the spot or the beam itself it looks nice, but then you take it further away and it's kind of not that precise.
A bit, yeah.
Well, this one you can have over great distances and it will still kind of have a spot. And you can also have obstacles in the way and it will kind of reconstruct itself around those.
Right, so it's like let's call it a clever laser beam.
It's a very clever laser beam.
So you can adjust to the environment.
Yeah, so then you had the one team thinking of using this for autonomous vehicles, so LiDAR applications where they were thinking, oh, but this can reconstruct itself. So snow and harsh environments, etc., could be very nice for kind of,
It's a laser beam, for detecting obstacles in front of the car and. Yeah.
Exactly, and then being able to operate in harsh conditions. So that was one of the. That was one of the projects, and the other team wanted to use it for communication purposes in rural areas.
Yeah.
So those were two projects based on the same technology, but in a different direction.
And this specific technology, this specific laser technology, is something that has been developed inside CERN, right? The students didn't take it from the outside. Yeah.
No. That's inside of CERN. Yeah.
That's the idea. Yeah. Wow. Very interesting.
Well, you can find it on the KT website. You were browsing the technology page earlier on. It's there. It's called
technology portfolio.
SLB, structured laser beam, laser, amazing laser, something.
Let's check it out, because this is very interesting. So if we go to portfolio, is it one of these?
Yeah, it's you see the rings?
This one?
The black, no, the other, the black and white. Yes, that one.
There you go, structured laser beam. Wow. Amazing. Yeah. So this is like a very good example, I think, of what can be achieved through that program. Your students, I've got a couple of other questions, but before we jumped out of this topic, where do the students come from? Obviously, they need to be master's students. Can they be from anywhere around the world, or do they need to be from member states, perhaps?
No, we do open for people from across the globe. Last year we had, I think everyone was studying in Europe, but two of them, they were from India and one was from Turkey. And one was from South Africa. So
there's an application process.
It's an application process, yeah. So you apply through the page you were visiting earlier on there, the Indico page. That's the CESP 2019 page on the other tab.
This one here, yeah. So
there, and then you see apply for CESP.
Apply, yes, great. So explain why, I guess, your entrepreneurial history and knowledge, to display that is one of the requirements.
One
your
thing is
assessment.
your
Right.
one thing is your history. The other thing is your motivation and kind of the future outlook.
Yeah.
So based on what you know and what you want to do, and your personality traits, could you be an entrepreneur? You have to attach different material and recommendation letters, and it's a bit like applying for a job. But it's really nice because we actually pay them, and we cover the recommendation, so that independent on where you're from, you can participate to this on the same basis.
Yeah.
So you're really judged, but what you know, not limited by the
Exactly.
resources you have.